The way we design, build, and operate buildings is undergoing a radical transformation. Welcome to ACE IoT Flight Logs. I'm Andrew Rodgers, co-founder of ACE IoT Solutions, and I've spent years immersed in the world of smart building technology. Join me as I learn from the industry's leading innovators, researchers, engineers, technicians, and more, how we can revolutionize the entire life cycle of the built environment. Get ready to take flight and explore the future of how buildings are delivered and operated. Hey folks, welcome back to another episode of Flight Logs. Today I've got Michael Melillo from Albireo Energy, and Michael and I have been chatting a little bit back and forth on LinkedIn about a topic that we both found very interesting and applicable to OT technology. So today we're going to talk a little bit more about how bringing SRE principles to operational technologies can really improve things and have a major mind shift in the industry. Hey Michael, thanks for being here.
Thanks for having me, Andrew.
Let's get started with just a little bit about who you are and what you do now, kind of where your a little bit of your history. I think that's always helpful to help folks understand the perspectives that folks are bringing to these conversations.
Sure. So I've been in the controls industry about 12, 13 years now. I was a mechanical engineer coming out of school, fell backwards into controls like a lot of people do. Never really knew much about it in college, but needed a job to pay off student debt. I worked for a distributor for a while, kind of learned how to size a valve, set up a Jace, field controllers, all that kind of stuff, wiring, worked for a contractor for a bit, came over to Albireo to really dive into the analytics problem. And that's the short version of it.
Were you aware at that point, when you came to work on analytics, were you already sort of frustrated with you were doing engineering and making, sizing things and designing things, and then, you'd find out later that it just never worked in the field, or you didn't get feedback, or were you in that world before you came? Were you aware of how painful that was?
I think only in the past couple of years I've come to appreciate how bad it was. So coming out of school and working on control systems, I didn't want to be a programmer at all. That's also the past couple of years I've kind of accepted that this is where I'm going in my career and really learned to love it, because learning coding in academia, I got all the wrong side of it. And once I had a real problem to solve, all the engineering principles kind of filled in the blanks. And I was like, okay, I'm hungry enough to actually digest this now. But I remember one of the first projects I did, we put in Jace with a couple of VAV controllers downside of it, and an IO board controlling that. And of course, the programming was terrible because I'm a year out of college. I have no idea what I'm doing. But you have remote access because nobody even knew what HTTPS was back then. And then we just had routers, or everybody opened up the firewall. Nobody cared. And you could just remote in Thursday night, Saturday morning, and you felt like a superhero. And it was great. And that ego trip fueled the beginning of we're taking care of our customers and stuff. This is awesome. And it wasn't until years later, and it really crystallized when I came across the site reliability engineering book, the SRE book from Google. I was like, this is the worst thing ever. This is absolutely right. And we got better at it over time, or I personally got better at it over time just from dealing with that pain. But it really was a shifting of the foundations for me that I need to rethink everything of how I build systems up from the ground.
I remember around the time the SRE Handbook was originally published, I was coming out of, or I'd been sort of head down in industrial automation for a while, very frustrated. And somewhere in there, I'd found some open source technologies. At the time, there was this technology called graphite, which was astounding. It was designed for storing fixed interval time series at scale, and you could do so much with it compared to factory talk historian or whatever that I was using in the industrial space. But it was crufty, man. But it was like one of the first duct tape and hot glue kind of solutions in the folks this large scale technology infrastructure operators had built. And it was just a file. It would initialize a file, and it would have a slot in the file, like fixed 32-bit number, slot in the file for every interval across, whatever you set your time for, and then it would just fill it in. Well, it turns out that's really fast. Like, it's really cheap and fast to do that at the expense of storage, but it was oriented, back then we had spinning disk. Like, it was just a completely different, anyway. But that's when I was like, oh wow, I need to be paying attention to what these technology people are doing, because they're iterating so much faster than we were in the industrial space. All that to get back to, I remember very vividly a talk I went to. I think it was at a DevOps Days in Pittsburgh. I might be confusing that. It was either there or Monotorama in Portland, but it was called From Hero to Zero. And it was literally about this journey of, like, as sysadmins in the previous world of technology infrastructure, before we got DevOps, before we got site reliability engineering, there was this same prevalence that you have with the 30-year controls tech that everybody in the company has to come to when something's not working. It was the exact same dynamic. And, you did get a little bump. I certainly did in the industrial space. Like, you get called in at 11. Yeah, you get called in at 11 o'clock at night, and like the whole line is down, and you walk in and you like, it's huge, right? But it's counter. Like, it's not good for the business. It's not good for society. It's not good for you. Like, we shouldn't be that wrapped up in our work, that's the only way we can, feel validated. But that hero to zero was such a, like, transformative talk for me, because I was just like, wow, okay. Like, I've been thinking about this all wrong. Like, very transformative. So it's funny that you bring that side of it up.
I love that you mentioned the hot glue duct tape, because I recently gave a talk at Skyposium where I talked about some of, like, the inner workings for what we're building right now. But I had an image. One of the slides was just Elmer's glue and popsicle sticks. Like, this is what we've been doing for decades, folks. Let's be honest.
Well, I mean, when we talk about, we're going to get into observability today, I think. Like, when you talk about that stuff, we just haven't been doing anything. We've been pretending it doesn't exist. In fact, a lot of the reason why you need that 30-year-old veteran to come out and figure out what's going on is because no one's learning how to diagnose these systems when they're failing. They're barely learning how to get them running in the first place. And because we don't expose the diagnostics information at a broad level, it's very hard to train. Like, how do you show someone how to, figure out what this stack trace dump from Java in the Jace means? Like, it's tough. So
that's totally it. People are scared of it. The trace is not, something I actually look at. That's something I send to tech support and pray.
Yeah, exactly. So I think a little bit of my premise why I was excited to talk to you. I'm a huge, we're going to talk about SRE principles at large, but I'm a huge proponent that just getting observability in this in the technology infrastructure in this environment will have a huge impact. And it allows us to then iterate and improve things, because we can measure where we're not doing well. And right now, the only signal we get is generally complete breakdown.
When I came across SRE, I was like, oh, this is where the gold is. Because when we talk about all of the fanciful promises that we make for our systems, all of the advanced things that we're hoping that we want to do, they presuppose that we can validate things are running correctly. And I think that's the foundation that SRE lets us set, is we can actually know we've got a system in a state that it's capable to do new things, more things, better things.
Let's get into, like, what SRE is. So I'll let you define it. I'll maybe add my thoughts.
So SRE is site reliability engineering. And the whole premise, there's one quote from the book in Google that I think sums it up, is what if you put one of your developers in charge of operations? And what if you said, what if we put in everything that we need to do to observe what's going on in our systems, to deal with the ways that they fail, to automate out the toil, the repetitive work that can be automated, not just automating for automation's sake, but taking out the stuff that is those repetitive opportunities for the kinds of mistakes that often get made, and drilling at that until you get to the bottom. I would say that's comprehensive, but that covers the heart of it for me.
Yeah, and I mean, I think from a more abstract level, it's really an engineering discipline for operations of technology. The other principle that I think is really key is reliability through managed change versus avoidance of change. So when someone tells me, I have an air gap network, it's secure, I laugh at that. I think that's BS in 2025. Like, that means you can't see what's going on in that network. It could be completely compromised and you don't know. So that's kind of in the same vein. And the same is true for, I have a reliable system, I never change it. What you have is a brittle system. And really, I think some of the arguments that we're going to hopefully make in the next 30 minutes or so are about changing how we talk about reliability. Reliability is not necessarily zero failures, it's uptime. And uptime is not zero failures. Uptime is doing what it takes to keep unplanned outages as minimal as possible. And sometimes that means you push a change and it doesn't work. But you have the infrastructure and the systems in place to revert that change and get back to your normal operation and go figure out what went wrong. And you have the observability in place to measure what went wrong so that you aren't making a guess the next time you try that change.
Definitely. When you mentioned earlier about like traditional engineering disciplines, I can even remember now, though it's close to 15 years ago, I'm getting older, but there was like almost a prejudice between the traditional engineering fields and software engineering, because it's like, coding's error prone. It's kind of the nature of the thing. You're sort of just clacking away at the keyboard. Not that it can't be done well, done professionally and proficiently, but
it doesn't, like, but let me just quickly jump in here. Okay, like, professionally and proficiently doesn't matter. Like, our engineering systems work because they have review built into them. They have permitting processes. They're all these systems that are meant to eliminate human error, because even in those more established disciplines, it's recognized the only way that they're made reliable is by recognizing that there is human error. Well, one of the things we're going to definitely hopefully folks walk away from this conversation with is how to measure how well your systems are performing, your OT infrastructure systems, and then how to talk about what you're selling when you're convincing someone that they should invest in this. It's that you're saying, okay, here's the outcome you're going to get, and here's how we're going to measure that outcome. And I think that's probably, that's what I hope folks take away from this is like, there's a better outcome, there's a way to measure that outcome, and there's a way to value that outcome. Whereas right now, I think we can't measure a lot of it, so it's hard to sell or describe or have confidence that you're getting what you buy when you start trying to talk about the outcome.
Right. So from there, do you want to transition into like SLAs, SLOs, SLIs as a framework for that?
Yeah. So in SRE Handbook, I can think of, there's 3 acronyms that I know that I know that if I from my memory, like that book sort of solidified, and sort of how they describe applying these processes to everything. So you want to break those down for us, Michael?
Sure. So we'll start with SLA, which is the one people usually hear about first from the outside in, right? Your service level agreement. And this is what actually shows up in a contract document. And it's more than just saying 99.9, 3 nines, 4 nines of availability or uptime or whatever. There's also like a hook in there. What's the contractual stipulation of what happens if you don't maintain it? And so that's kind of the thing that ties it all together at the end of the day. That's going to show up, and here's what I'm going to do, and here's what happens if I don't do it. The SLO, service level objective, is that measurable thing. And it doesn't have to be like directly measurable with a temperature sensor or something like that, but it has to be something that you can agree and formalize into some formula of how I calculate this thing. What might be more at hand is a description of how I justify energy savings. I should be able to formalize what that is. Hopefully it's not totally nebulous. Hopefully it doesn't look like a comfort index or something like that, because often we get away, we call them numbers because it's nice to put a percentage on a gauge. This should be something that we can get a little bit brass tacks about. And then down way at the bottom would be SLI, which is a service level indicator. This is something that we can pretty much directly measure. We can say that a service is up or not. We can measure a temperature on a CPU board. We can measure what the current memory allocation is on a heap stack or something like that. And they may be the raw inputs that we calculate higher level SLIs or the SLOs, which might be like our internal objectives of here's what we want to maintain so that we know we're never going to breach contract for our client.
SLA, SLO, and SLI. Those are
Yes.
the keys. And the SLA is something that there's consequences for, right?
Right.
And if you have something you have consequences for, don't you want to be able to know when you're getting close to those consequences? Yeah, so you really have three things you can optimize for. It's confidentiality, right? Like a lot of times when we talk about general IT systems, we care about keeping things private. That's people's information, it's their medical records, whatever. Like confidentiality is really important there. It's integrity. So if someone has a medical record and it says that they're healthy, you don't want to be able to go in and change that to something else, right? You want to be able to know there's been changes. And then availability. And generally, when we talk about how we organize general IT technologies that are, business intelligence, all that sort, they're sort of in that order. That's what we care about. Like, we'd rather know we kept it confidential, then we'd rather we know we kept it, untampered with, and finally finally it needs to be available. So if something goes wrong with the system, you shut it off and figure out what's going on, then you bring it back. In OT systems, we really care about it in a completely different way. We're much more concerned about availability. Like availability is our guiding star. We need these systems to be online. They have to be delivering comfortable air, cool water, whatever we're doing. And then it's integrity. Maybe integrity is as important as availability. We argue that back of whatever. But ultimately, if someone's putting in fake data to your system, they can probably influence its behavior in a way that's not great. And finally, confidentiality. Like, who really cares if someone knows the temperature of your water? Nobody, right? Like, it's just not that big of a deal. So, thinking about that, this availability thing is really what your SLA is probably going to be tied to, right? And when we talk about this and error budgets, there's this other acronym that I latched onto from this world that I just don't think gets talked about enough, specifically in buildings. It's a little bit more prevalent in critical infrastructure and industrial side, but mean time to recovery, right? Because humans make mistakes, right? We started there. Humans make mistakes. And you have an error budget. So let's say your error budget for the month is an hour. You can have the system availability compromised for 1 hour. If it takes you 3 hours to recover the system from an error, you will never be able to make a change in that system following these principles we're talking about, right? So moving that needle, if you take nothing else from this talk except in this conversation, except figure out how long it takes me to recover from an error and work on the systems and processes and infrastructure I need in place to reduce that. That is the biggest takeaway, because now you have budget for more changes. If you get that recovery time down to 10 minutes, that means you can make 6 changes a month. 5 of them can fail and you can still make another change. And that completely changes your velocity and ability to deliver, changes and upgrades and systems that continue to operate. MTTR is my favorite acronym that we're going to talk about, because I just don't think and it has cybersecurity implications. This is what it means. Like, if your system is compromised, how fast, how soon can you recover? All those things are really the key path for these OT systems is how fast can we get this back online.
To build off of that, I think it's really useful to talk about, to do that. I don't want to go all the way to deterministically, but at least have some idea that you're going to be consistent with this recovery time, just how far we have to go as an industry, and how far I think in some ways we need to lead the OEMs along and just kind of grab them by the chain and say, here, we're going here, come on. Because I can wildly deploy backups and be back up in 5 minutes, or I could not. There's an implied ability to diagnose the problem in a real recovery. Anybody can throw darts at the wall and get lucky in under your SLA time. But it takes a strategy, and having deployed that strategy beforehand to be able to do that consistently. And that implies a whole host of things, but we'll go further into it. But one of them is to be able to observe as SLIs, these leading indicators that something is gonna go wrong. To be able to understand when you deploy some change that is hopefully going to lead to this recovery, that these metrics are going the direction they ought to be going. It also means that if part of your strategy, maybe you go as far to have a playbook, if part of your strategy involves deploying backups, you've already like presupposed that you have a way of knowing the backups you're keeping are good. And exercising backups in the BAS world, right? Do we have a host somewhere that for across all the OEMs we support is spinning up like a Docker container for the ones that can run in Linux even, and that can support the licensing model to do that? This is just to talk about how big the problem is industry wide, that we can deploy this, run a customer's backup of the most recent one and say, okay, I know I have something I can go back to. And that's just, there's all these things of you have to be able to observe what it is. You have to have a plan for what to do if something goes wrong. You have to be able to observe when you make the change that something goes well, and you have to be monitoring the assets that you might use for that recovery. Otherwise, it's all just, like you were saying before, it's brittle, and every change is risk.
I think there's you're talking about it very much from a service provider perspective. I think there's something that can be taken away here for facility operators and managers too. There's going to be a few service providers who are out in front leading the way like you're describing. I think a lot of them are going to lag, and they're going to need to be dragged along just like the OEMs. So, this, hopefully you're getting some language to think about including in your next contract, because that's how you're going to drive. That's how we're going to drive change, is the owners and operators demanding this from the service providers, who will then demand it from the OEMs. But also, hopefully, there's stuff you can take from this that are immediately actionable with your internal team, right? Like exercising backups. That's, we're going to talk about a lot of stuff that's pretty high level and is going to require a lot of change to get there. But if you can just exercise your backups at least annually, you're so far ahead of so many folks in this industry. And then even if that's considered too risky for your organization, just starting with the tabletop exercise, right? Like if you sit down once a quarter and discuss one of these scenarios and how you're going to respond to it with the partners and team that you have access to in your organization, that puts you, because this goes back to your point, like you're not throwing darts anymore. Everybody who's involved understands that, okay, I have a role to play when something goes wrong here. That brings you back to these tabletop exercises, which I think every organization can do. It's such a low stakes thing. Buy lunch for your team, sit down and talk about what happens when the Jace dies, what happens when there's a hack, or your IT team tells you there's a hack and they cut off your supervisory server from everything. Like, what do you do? And I think that gets you a long way on this MTTR thing.
To build off of that, just a quick second, just because that also is a great way, I would say even like internally, service providers need to be doing this, but then also inviting customers to the table to do it as well, because like there's two directions, if you want to call it like a carrot and a stick, or from the spec and the negotiations. There's got to be like a requirement that the people, the facilities personnel, or the teams that are running these buildings has to put down in paper that we expect this to happen. But then that also has to be complemented with like, it won't be successful if we sort of just lambaste each other with spec language and say, okay, go make it happen. That meeting provides the opportunity of bringing everyone literally to the table to say, where's the technology at right now? Like I brought up the example of, oh, we should do these Dockerized deployments and automate our exercise. I want to be there. But what we can do today is don't balk if I put in my service contract language that I'm going to exercise backups. And the procedure for that right now to work with the tools I have is our technician is going to work with your assistant chief, your chief, or something like that. And we're going to walk through the backups once a year. And that's going to be one of our visits. And you've got to be okay and buy in with that I can't do your hot cold calls today and help you with that. And we got to balance what the requirements are so that we can start building these things that do more than put out fires.
Exactly. All right. SLIs. This is like the foundation of all this, right? These are the things we can measure, and they sort of intertie with this concept of observability that we've talked about a little bit. But these three pillars that were sort of what was around when the SRE handbook was written, for sure. So metrics, logs, and traces. And really, traces are tough for OT systems. So I think we can pretty much throw those out for now if we can just get good metrics and logs infrastructure. So metrics, these are generally scalar numerical values that measure something about your system. This is how many packets are on your backnet network, how many are global broadcast, how many read property requests, how many COVs, etc. It's how much CPU is your controller using at this moment, how much memory. Like, those are all metrics. Those are measurable things. Our applications generally generate a lot of information in logs that are not necessarily directly measurable, and they can be complicated. I think the problem with logs in general is that a lot of times, this one application emits logs that look a lot different from each other. So each line can be completely different because it's coming from a completely different subsystem, and that makes it more unstructured. So generally with logs, we process as much as we can from them, but we want to make them available so that we can look at them not just for right now because there's something broken. Most of us have that capacity. Like, I'm sure, you can log into a controller that's down for some reason or not doing what you expect it to, and you can look at the log. But what's really helpful with centralized log infrastructure, which is really what we're talking about observability platforms, is the ability to say, okay, I've got a problem right now. The logs look like this. I want to go back 3 months to when this system was working perfectly fine. I want to look at the logs there, and I want to compare them so I can see what's going on. That sort of ability to do that across every piece of equipment without having to take a laptop out and plug into it, or whatever your normal sort of deep dive, like, that's what we're talking about. We're talking about observability. Sorry, I know I'm really into observability, so I jumped on the lead there, but anything you want to add there to that definition?
No, you're good. I think we need to be, I struggle a lot with how do I meet where I'm at right now? How do I meet the people I work with, and how do I meet the industry with the tools that are available to me, where they're at, in a way that I can help, like, cast direction for where I think we can get in a month, 3 months, 6 months, so that I know we're making progress. Because if there's anything the buildings industry has taught me, it's that it'll take longer than I think. So I think, like, being willing to sort of take a shovel and dig at the mountain is necessary sometimes. At the same time, like, what you talk about where to go with logs is nowhere where we're at in kind of like an organized infrastructure right now, to be able to deploy that. And something that I struggle with as well is balancing how to deploy for, like, BAS in the cloud in some kind of connected infrastructure world versus being able to help people who are deploying totally on-prem. And I think one of the most important use cases there is folks who are like these 80% of smaller, mid-sized commercial buildings. I think that'll always be a thorn in everyone's side. It's easy to deploy for places that have all of the infrastructure, and teams who think about or have even brought some of these ideas to the table for us to say, hey, we do this with our other systems. Like, we have Datadog deployed, or this, that, and the other that are doing some of these SRE things already. What can we do from, like, a white box perspective is one of the metrics pieces that I really find utility diving into. And when I say white box, just for anybody listening who hasn't heard it, white box is access to the internals of the system, right? I can go inside, I can peek at even proprietary things because I'm working with, like, first party tools at that point. I can ask, in like a Niagara case, I can ask a Tridium Jace details about its diagnostics that you couldn't do externally. And that would be more like a black box application where maybe I want to know if the website's up. I should just ping the website or something. If I get a response back, that's black box, right? I don't get anything about the internals of that system. So white box metrics has been our first real stab at useful data that we don't have right now. And it also seems data that other folks have a hard time. Like, we're best leveraged as a systems integrator to go after the metrics of the devices we deploy, and then use those to determine the health of our system.
I think, just to clarify,
Yeah.
there's in-band and out-of-band and white box, but you can expose internal things from Niagara to an out-of-band collection system. You don't necessarily have to, like, you could have you could have some application logic running in Niagara for it, just as an example, that takes system metrics and exposes them in a way that's accessible from an out of band metric system. So you can do both. I guess is all I'm just trying to make sure they're connected. So, and I know that this is, I think, the little bit of attention here is like I think most of this stuff should be out of band, because you don't want the system that's monitoring itself to be how you're troubleshooting the system. To your point, starting at the mountain with a shovel is important, right?
The article that you wrote, like SRE for OT, was one of the match strikes for me. It was like, we should just be talking about this as an industry, because it's one of the things we don't do. It makes the systems better, and it gives more people examples of where we could be. Because I almost want to say, maybe it's like Brian Turner from OTI always talks about, like, one of the big risks is we're not competing against the other guy, we're competing against doing nothing. And that just sums it up so well. We have so many, like, if our goal here is to deploy these better systems and to enable this like technology adoption to do better stuff, whatever that may mean in a particular context, we need to sort of cast direction, whether in the small with the shovel or in the big with the bulldozer, and show people that, like, there's a road forward, that we can get there, and that it's also not just like ivory tower Googles or people like that. And I think that's one of the other things that is like a apprehension for folks who have been boots on the ground for so long. Every external entry into the building automation market has been, was it like Cisco back in the early 2000s and other companies that, like, these $1 billion that are like, we're going to solve buildings, and they come in and sort of like just smack their face into the mountain and it doesn't move at all. And we all kind of snarkily sit here and go like, yeah, thought so. But there's real chance and worth in changing this. Not for nothing, this is going to make my life as a systems integrator better. Like, do you know how much better I sleep when, man, we deployed last week? There's a part we're overlooking about how nice it is to deploy systems and software that's built to minimize toil, and how much that doesn't just like rip my soul out, that I don't have to click every button for it all to just start working. Because you put the onus on building the systems and the tools that build the systems better. But we deployed this last week for a client, and over the weekend, we got some diagnostics back for a new site that they had onboarded. And we got some alerts that, like, oh, these JACEs that are installed here they're screaming for help. The backup maybe is taking like an hour, right? And the only real tangible piece that anybody has is it feels slow. And it's like, these controllers they're just waiting for a watchdog timeout. They're dying to do it. They're just flipping the coin every night. And it's like, hey, we saw that. We found that. It didn't have to take hours to deploy. We didn't have to try to recover the logs from a crashed controller. We saw the pattern before it happened. And now we can pull people into the room to start fixing problems. Like, I hesitate to use buzzwordy stuff like, oh, it's preventative maintenance or whatever, because it just as likely could have crashed, right? I'm like, let's resist that temptation. But if there's a road to keeping systems healthy and not having to worry about mean time to recovery, but getting ahead of the crash, that's the world I want to live in.
Yeah, I mean, I think like the whole thing with the preventative maintenance is like, maybe you're not getting turnkey preventative maintenance, but you're certainly not going to get preventative maintenance without this information.
Exactly. If there's a way to get there, it starts here.
So let's talk about SLIs for BASs. This is I think a lot of people would read some of these principles and be like, what is that like? What is the difference in Gmail being able to send an email in this many milliseconds versus like, how do I apply that to my BAS? So what are you finding are meaningful SLIs when you go to apply these?
So my first target has been the article I wrote a couple of weeks ago is the network control engines, JACEs, automation servers, SNEs, whatever flavor it is of BAS you have. Chances are you either have these virtualized in server or these hardened edge devices that are out there in a control panel. And they're kind of like these major arteries, these major runways in your system. And if they go down, a lot of stuff starts to head south. At the very least, you're going to lose controllability of whatever's downstream of them, right? Ideally, they're running with local sequences, but it's a black box now. So exposing the other benefit, I guess, is the internals of those systems are easier to expose. They have some of the more robust toolkits, especially for existing deployments that we have where there's still serial networks and things like that. It's a lot of bandwidth to add to the network to go to every VAV box and start exposing CPU. So to do that at the network level, and I'm looking at other controllers soon, like Distech has the REST API on their IP level controllers. For field level unitary controllers, they're going to be like my first target for that. But that's a lot of where I've been honing in right now is like your remaining disk space on those, your CPU, your volatile memory, your heap, and how your resources are just sort of allocated in those controllers, mainly because they're very at hand.
And then, I mean, I think for those, like what we measure for those controllers where maybe they're not even programmable, so like you can't do a white box model. It's a completely, obscure, or not obscure, but opaque, configuration driven controller or something like that. We look at stuff like command latency, right? So like we're writing a command or we're reading a point from some VAV somewhere. How long did it take? And is that trending up or trending down? Like we try to baseline some of those things as SLIs for those devices that maybe we're never going to get the kind of metrics that you're going to be able to expose with that Distech with the REST API, right? Like some of this stuff, we just have to recognize that we're probably not going to get to the ultimate goal. What about like I've actually seen in some OPRs, and so I'm curious if y'all are tracking this yet, but like login times and time it takes for a BAS paid graphics to load data, like that sort of stuff, is actual SLAs in the OPRs. Like, are you tracking SLIs for that so that you can have SLOs so that when you're headed towards?
So today, no. And this is one of the things where I think like recently we launched sort of the private cloud infrastructure offering for Albireo, and not to turn it into a sales pitch for that. You can shoot me if I do. Uh, but one of the things is by deploying that way where we own and control the infrastructure, one of the hardest things for adding pieces to the stack that might help us observe that stuff where the OEMs or the deployed software either doesn't let us do that easily or requires some extra layer to observe that. When we own the entire infrastructure, we can start to decide to do those things and experiment with the best game plans. And so that I think would be a high candidate for like a roadmap of at least internal metrics we want to do to say how do we measure up.
And once we have these things, like you mentioned this about earlier of like, oh well, the trip out to your site that month, we're just gonna have to do backup recovery. We're not doing hot cold calls. But like, isn't the goal to get these things in place, and then your contract's not based on how many times you go to site or how many hours you spend there? It's based on the outcomes. And then you tell your client, like, we're doing backup recovery because that's what's going to give us this SLI that allows, that's what influences our SLI that allows us to deliver this contract at this price and with these outcomes.
One of the most humorous things about us talking about this together now on the podcast is another like kick that got me going down this road was a bit of skepticism. I think it was an article that maybe you had helped contribute to with Nexus Labs, and it was talking about this like no longer hours based building systems service contract. And at the time, because anybody who's worked with me knows I am much more prone to take a very opinionated stance and either be right or wrong or something, but I have something to work with by doing that. And so I was like, Andrew's full of it. Let me figure out if I can go somewhere with this, because it just seems so alien because of the way we do things right now as an industry, right? Which also includes us. And so what led me to SRE was thinking about what would the world have to look like for me to start being able to shape the business terms that are a non-hours based service industry. And I have to have a reliable system. I have to be able to measure like the granular bits and pieces about how my system's operating before I can even start to say, well, what are the services I'm providing and how am I measuring the success and the efficacy of those services minus the deployment of hours. And it requires, it's like you've presupposed the ability to determine your system is reliable. You've presupposed the ability to get it back up and running in some relatively fixed span of time. Like you can't talk about backup exercising or that being part of a playbook to deploy recovery and that your central chilled water plant is going to be back up because to cast vision for like a dream, if I get mechanical designs and it's N+1 or N plus whatever redundancy in the chiller plant, because the mechanical engineer who's doing traditional systems engineering has calculated the heat load in the data center that this chiller plant is connected to, and he's figured out that if I go down, I've got X minutes at a riding 74-degree Fahrenheit set point in my racks. Before I start flying out of SLAs from the manufacturer for these servers, and I start risking whatever that is for like a colo data center provider. If I have that time metric and I can incorporate that kind of idea into my service contract where I say, based upon the engineering design of your system, you're required to have a X9's uptime in your systems, and we can validate how we'll recover your chilled water system. So it's not just, oh, the chiller tripped on high head. It's the chilled water plant network coordinator controller is dead. And your engineers, without having to call us, have a playbook to deploy a tested backup and be back up in the boot time of that controller. That's the world I'd love to live in. SRE to me is the foundation of building the other. There's a lot more work to do than just measuring CPU, but it starts here.
Yeah. Where would you say people should get started? So we talked about this SRE as a framework. Obviously, read the SRE handbook. Maybe.
It's a bit dry. Again, that's why I recommend. I've done most of it via audiobook because I torture myself running. Maybe you do similar things when you ride your bike. So you go on some pretty long routes there, but that's been a way for me to digest things. And oftentimes if I get through a page or two while I'm running, because it's like, oh, I got to listen to that again. Wait, that was really good. But thinking about how to deploy or thinking about what your world looks like if you didn't have to manually click and deal with every button it is to deploy a system. I think one of the best appeals for a system integrator is the idea of reducing toil. If you, instead of like, I think like a decade ago, I was scared to automate too many things because it's like, then I'm not in control of it. And maybe I write buggy code or something like that. But it's like, you've got to choose to impose your standard somewhere of where the quality and grade of your work is going to be. Make it in your own tooling, right? And take care of your tools in the same way that I often laud the guys who do the field work for us, because my career is literally built on the back of what they deploy. I should take care of my software toolkit the same way, and I should act like a professional with that. And if I reduce the manual toil and cruft that it takes to get something built, that I think is one of the most immediate bits of payback to see the value of this kind of mindset.
Where should we start with measuring? Like what's the first thing to measure? Is it just CPU utilization on your supervisory devices? That seems pretty. That I've been in a lot of situations where if we'd have had that as a leading indicator, boy, would it have saved some trouble.
I'm biased to that because that's what I did. Take the last thing that crashed and do that.
Well, thanks again. This is Flight Logs. We had Mike Melillo with us today from Albireo Energy, and that was hopefully how to apply SRE to your OT environments. Thanks again, Mike. See you soon.
Thanks for having me, Andrew.